The graph shows the amount of money earned by an employee based on the time he spent working. Okay, which list shows the dependent quantities in the graph? So I've got my X and my Y, and I have, if I make an input-output table, okay, or my independent, dependent variable, so my X is my time spent, and then my Y is the amount earned, like the dollars earned, right? So we've learned that our independent is our X, right? So here's our independent, and our dependent is our Y. So we're looking for the dependent. So I'm going to go ahead and just look at these points on the graph, and this first one is 110. So my X is 1 and my Y is 10. The next one, my X is 2 and my Y is 20. And then my X is 3 and my Y is 30. And then my X is 4 and my Y is 40. And my X is 5 and my Y is 50. So my dependent will be these numbers right here. So therefore my answer is going to be F. Okay, the table shows the relationship between D, the amount of money Alice has at the beginning of each day, and W, the amount of money she has after riding the bus to work. Which equation represents the relationship in the table? So I'm saying, what am I doing to D to get to W, right? So I need to figure out what am I doing. And if I'm looking at my D and then my W, I notice that my numbers are getting smaller. So what do you think could be happening if it's getting smaller? Looks like I would be subtracting, right? So let's look to see how much could I be subtracting. So if I did $15.75 minus $14.50, okay, that's 5, 2, I bring that decimal straight down, and that's 1. So that's a $1.25 difference. Okay, and that makes sense because she's riding the bus. So she's paying to ride the bus. So I'm subtracting $1.25, right? What about from $9.50 to $8.25? Okay, I know that 50 cents minus 25 cents is 25 cents, and $9 minus $8 is 1. So again, I'm doing minus $1.25. So what am I doing to the D? I'm doing minus $1.25 to equal that W. So we've done a lot of like X and Y, so we would say Y equals X minus $1.25, but instead of using Y and X, it's using W and D. So W is equal to D minus $1.25. So that means my answer is going to be J. Okay, the graph shows the number of points Y a player earns in a balloon game based on the number of balloons the player pops, my X. Which equation best represents the relationship between X and Y? The first thing you need to do is make an input-output table, my X and my Y, and I'm going to get my points from my graph. Okay, so when my X is 1, okay, I know my X is 1, and it looks like my Y is right in between 20 and 30. And what would be right in between 20 and 30? 25. Okay, so all I did is I got that coordinate was 125, my X coordinate and my Y coordinate, to get my ordered pair of 125. Now I'm going to look when my X is 2, okay, when my X is 2, what's my Y coordinate? 50. So I'm going to put that in my table. Okay, what about when it's 3? This is 3. My Y is 75. Okay, so what am I doing? Remember, I want to know what am I doing to X to get to Y. Now, we forgot this one right here. That's at 0, 0. So the fact that it's at 0, 0 means, is it multiplicative or additive? It's multiplicative. So I know right now my answer is not A and my answer is not B because it goes through the origin. And if it goes through the origin, it is multiplicative. I have to be multiplying, right? So what am I multiplying to get to my answer? So what am I doing to 1 to get to 25? I could say I'm multiplying by 25. What about to the 2 to get to 50? I'm going to use a dot to represent multiplication there. 25 and 3 times 25 is 75. So I'm saying x times 25 is equal to my y. Okay, so when I talk about my rule, I'm always going to start with y equals, right? And then to show that I'm multiplying the 25 times the x, I'm just going to put 25x. And remember, that means 25 times x. So is it C or D? The answer is D because C has the x and the y reversed, but I'm not multiplying the 25 times the y, I'm multiplying 25 times the x. Okay, which table shows only values that represent the following relationship between Q and R? And it says R equals Q plus 10 and 1/10. So what I'm saying is, which one am I saying adding 10 and 1/10 to the Q? So I'm saying I want to add 10 and 1/10, if the stylus will work. Okay, 10 and 1/10 to all of these. And I want to know which one is correct. Okay, so I need to test them. So I'm going to plug in those numbers, okay? So I'm going to say for the first one, if my Q is 5, then I need to add 10 and 1/10 to that. So to add and subtract decimals, that's when you stack up the numbers, keep the decimals in line, add any needed zeros in, you'll be just fine. So I'm going to put a decimal and a 0 right there because I need to line them up, and I bring that decimal down. And 1 plus 0 is 1, and 10 plus 5 is 15. So I already see that that's not it, and that's not it. Now this one's correct, and this one's correct. So now they have the Q as being 7. So let's add 10 and 1/10 plus 7. And I'm going to line up those decimals, right? And put the holes with the holes and the parts with the parts. And 7 was a whole. Okay, so I'm going to add that up, and I get 17 and 1/10. And that is correct, and that one is not correct. Okay, and I could keep going. I could say 10 and 1/10 plus 9, and again, put the holes with the holes and the parts with the parts. And I'm going to get 19 and 1/10. And 10 and 1/10 plus 11. Okay, that's going to get me 21 and 1/10. So that's correct. So my answer is B. Okay, which table represents the equation y equals 3x? And remember, what does that mean? That means 3, when there's no operation sign, it means multiply. So I'm really saying 3 times x. Okay, so I want to know which one equals y equals 3 times x. So that means I'm multiplying the x times 3. So whatever I do, I'm going to multiply the x times 3 to get to my y. So if I look at f, 3 times 3, I'm going to multiply that x times 3. So 3 times 3 is not 1. Okay, it should be 9, so that's not correct. Okay, so I can already get rid of that choice. If I look at g, I'm going to multiply this by 3, and 1 times 3 does equal 3. 3 times 3 equals 9. 4 times 3 equals 12. 7 times 3 equals 21. Okay, so that is correct. But y'all, I can't tell you how many times I see these little mistakes. So check them all just to be sure, okay? So H, 1 times 3 is not 1. So that cannot be it. And then J, 1 times 3 is 3. But 4 times 3 is not 9. So it's not that. So my answer is G. Okay, we're going to do one more. Which table could represent the equation y equals 0.1x? Okay, the first thing we need to understand is what that means. Okay, that means I am multiplying x times 1/10. So whatever I have my x, I'm going to multiply that times 1/10. So I know I need to multiply it by 1/10 because again, when there's no sign, it means I'm going to multiply. So if I start with 5 times 1/10. Well, when you're lining up when you're multiplying by decimals, you don't have to line them up. 5 times 1 is 5, but there's really a decimal point right there. So that's one place. So there's going to be one place there. So that means if my x is 5, my y should be 5/10. So that one's correct and that one's correct. This is not and this is not. Okay, what about 10? Okay, 10 times 1/10, okay, is of course 10, but you've got one decimal place. So I have 1.0. I don't actually need that 0 because it has no value, so it's really just 1. But right here it says 1.0, doesn't it? So that's correct and this one is not. So I can tell right now that my answer is going to be G.